Hi everybody. So in this video, we're going to go through the molar conversion guided notes. So this is to end your lesson on what is a mole, and then it's going to essentially lead into your follow-up activity, which is some practice questions. So I'm going to open up the document, and you guys should have it available as well. Either print it out, write some stuff on loose leaf, or you can type along onto your computer through the doc. So once again, like I said, we're going to go through the grand mole conversions guided notes here. So I'm just going to be writing along through this. So now that we've learned how to calculate molar mass, today we're going to see how we can convert these values into real masses, and then also vice versa. Before we get into that, I just want to recap how we calculate the molar mass of a compound. So we're going to use H2O as an example. So just a reminder, you are going to need your periodic table. So use the reference table version of it. Actually, I'll open up that as well, so we can do that. Here we go. So let me scroll down to the periodic table. And of course, if you have your paper copy, that is probably even better. Oh, here we go. So, okay. So once again, we're going to take a look at calculating the molar mass of H2O just as a kind of review from class. So H2O, water, dihydrogen monoxide, you may remember. Oh, didn't plug my board in. Okay, sorry about that. So to calculate the molar mass of H2O, what we're going to do is look at the atomic masses of each element within the compound. So if H2O, so the two elements we're dealing with are hydrogen and oxygen. And then the subscript 2 tells us that there are 2 atoms of hydrogen. So this 2, just as a reminder, refers to the H here. So the subscript always follows the element it's referring to. So to determine the molar mass, we have to look at the atomic mass of each and then just multiply them by their subgroups. So H, hydrogen, has the atomic mass of 1.00794. I'm sorry, this is going to keep going back and forth because the ink stays no matter what tab I'm on. So 1.00794. So we're going to put that in. 1.00794, and it's atomic mass units. And for oxygen, if we go back to our periodic table, we'll see that oxygen here has a mass of 15.9994. So 15.9994, also atomic mass units. So one hydrogen is 1.00794, and one oxygen is 15.9994. We'll do the rounding at the end just to get as accurate as a number as possible. So because we have 2 hydrogens, we're going to multiply this value times 2. Now, just use a calculator, not forcing you to do math in your head or anything on the regions. So you'll have availability to use a calculator. So why not? 0.00794 times 2. Not yet. 2.01588. So 2.01588 AMU, and that is for hydrogen. Oxygen, we would multiply by 1, but we know multiplying anything by 1 will give us the same number. So to determine the molar mass, we're just going to add these 2 values up. Running out of space a little bit here, so I'm just going to do this on the side. So I would take my 2.01588 plus 15.994. Add them up. This is my calculator, real time. 15.9994. And you should get 18.01528. 18.01528. For the most part, we're going to round to the nearest tenth. So let's take care of that. Even, you know what, let's say, yeah, the nearest tenth. So our molar mass here is going to be 18.0 grams per mole. So that means that in 1 mole of water molecules, or 6.203 times 10 to the 23rd molecules of water, it's going to have a mass of 18 grams. Okay, so that was just a reminder as to how we calculate the molar mass. So this was gone over in class. This should be relatively familiar. Now I'm going to clear this. I'm going to move on and go over how we're going to do these molar conversions. Clear and scroll. So now this is something that's useful in chemistry, but we chemists don't measure things using moles. So there's no like scale that we can pull out that says like, oh, this is 3 moles of a certain amount of compound. So, or for that matter, number of molecules. When we're actually doing stuff in the lab, we need to actually measure masses in grams. But the idea is that we need to convert these grams into moles or vice versa to get the appropriate amount of each compound that we need. We're going to see how this becomes more useful when we start looking at chemical reactions and how they balance. But to start, we're going to just basically look at this relationship, which is found on table T. So on the last page of your reference tables, you know what, I'll flip to it just so you can see. So I'm going to have to re-rotate this. So if you go, it's the second row down here, mole calculations. So number of moles equals the given mass over the gram formula mass. So gram formula mass is just another name for molar mass. There's a few synonyms that you should just be familiar with. But let's jump back. So actually, I'm going to scroll back up to the periodic table. We're going to go back to that in a minute. Oh, no. Sorry. There we go. Okay. So, and I just put this in here so you can refer to it as well. So as I mentioned, molar mass has a few other synonymous names, so let's keep that in mind. So molecular weight is another one, or gram formula mass. So technically they refer to different types of compounds, but we're not really going to get into the details there. But the goal here is to essentially create proportions that allow us to determine how much mass is needed for a certain number of moles. So let's see how this works. So if I have 3 moles of sodium hydroxide, which is NaOH, or polyatomic ions, I want to know how many grams that is. So if I go into a lab stockroom and I say, oh, for this reaction, I need 3 moles of sodium hydroxide. Maybe I'm making a solution, maybe I'm reacting it with something. I need to know how much of that I'm going to pour onto a scale and then bring back into the lab. So to do this, I would like you guys to really follow along with this little equation here. It's going to help you in making sure that you're setting up the math right and doing the correct operation in the end. So I'm just going to rewrite it. So number of moles equals given mass over the gram formula mass, or the molar mass. I'm just going to write molar mass. Less words, less letters. So we're just going to kind of like figure out what we have. So we have 3 moles of sodium hydroxide. So that is going to be our number of moles. We have 3 moles. We want to know how many grams that is equal to. So that's going to actually be our given mass. So how many grams is going to refer to our given mass? So actually, we're not given one here. We're going to try to find it. And then the molar mass, given that we know the compound, we can determine what the molar mass is. So we're determining the molar mass of NaOH because that's the compound given. So first thing we need to do, we need to determine the molar mass of NaOH. So let's take a look at the elements we have. We have sodium, Na. We have oxygen, and we have hydrogen, H. So we have hydrogen and oxygen from before. So O was 15.9994 AMU. H was 1.00794 AMU. And sodium, let's double check our periodic table. Make sure we're using the values here. So sodium is 22.98977. Let's jump back there and write this in. So 22.98997 atomic mass units. So again, we're going to add these up to get our total molar mass. So I'm going to pop that into my calculator. You guys do the same. 98977 plus 15.9994 plus 1.00794. Okay. So I got, 39.99711. So the molar mass here is 39.99711. And for the sake of rounding, I'm just going to say that it's equal to 40 grams per mole. So 1 mole is equal to 40 grams. Now we have some more information to help us figure out this question. So let me just put a box around this. Okay. So, like I said, we know the number of moles. So we're going to fill that in. That is going to be 3. So 3 moles of NaOH. We also now know our molar mass. So we know that 1 mole of sodium hydroxide, NaOH, is going to be equal to 40 grams per mole. And we're still looking for the given mass. So we're looking for this value here. So I'm just going to throw down an X as my variable. X grams. So we want to know essentially how many grams are equal to 3 moles. Now here, you're just going to use your algebra skills. We know that if we're solving for X up here, we need to isolate it. So to do that, we're going to do the opposite operation that is present. So the current operation here is division. We know that because it's set up like a fraction. So to take care of that, we're going to multiply both sides by 40. Times 40 grams per mole. Here, everything is canceled out. And then here, our moles are canceled out. So that's where the unit gram is going to end up with. And we're going to be multiplying 3 times 40, which is going to give us 120 grams. Okay, so just to recap, I determined the molar mass of NaOH, and that was 40 grams per mole right here. So that was the molar mass. And then I plugged everything into the given equation. We had 3 moles as our number of moles. X grams was our given mass, so we weren't given a mass, we were trying to find it. And then our molar mass, or our gram formula mass, we calculated before. That went down here. Plugged everything in, solved for X, and we got 120 grams is equal to our 3 moles of sodium hydroxide. Okay, so now that we've seen this, we're going to kind of do it another way. So here we went from moles to grams. Now we're going to go from grams to moles. So I'm going to scroll down here. I'm going to clear this. And in this one, it says, you are given 36 grams of water. How many mole is that equivalent to? So once again, we're going to use the same formula. So I'm just going to actually write it up here just for some more space. So we're going to follow what was given. We have number of moles equals given mass over gram formula. So number of moles equals given mass over gram formula mass or molar mass. Okay. So now we're going to look at what we currently can plug in. So it says we are given 36 grams of water. So we have our given mass right here. So 36 grams is going to go up top. How many moles is that equivalent to? So we are solving for the number of moles here. So I'm going to put that down as X. So X moles of H2O equals 36 grams over our gram formula mass. Now, we calculated this for H2O already, so water H2O. So you can go back up to your notes previously to get that. You may recall that the molar mass of H2O was equal to 18.01 grams per mole. For the sake of ease in terms of the math, I'm going to actually just round this to the whole number. So say 18 grams per mole. You'll probably see why that works. That's helpful. So we're going to plug that into our denominator. So the gram formula mass here is 18 grams per mole. Now we just solve for our X. Works out that everything is already set up in terms of this equation. So we're just going to be dividing 36 by 18. By dividing grams and grams here, we are canceling that out, leaving us with the mole. So if we are given 36 grams of water, that is going to be equal to 2 moles of water. So that is how you go from grams to moles. Okay, so hopefully you took this in, feel pretty decent about it. The follow-up activity is to complete the practice questions as well as a quizzes activity afterwards. Just a quick little tip here. I'm going to always suggest that you write out the formula that is given. So always use this as a guide. Oftentimes I'll have students ask me, oh, do I multiply here or divide here? As you may have realized in this, when going from moles to grams, typically we multiply. When going from grams to moles, typically divide. But if you strictly use the formula here, you will then be able to figure out what mathematical operation you have to do. So no one's going to force you to do the math in this particular way, but we are going to be checking your work. So please make sure that to better help you here, I can only suggest using this formula that's given. Okay, so now continue on. You can work through the follow-up activity and reach out if you have any questions.